All right, so a lot of you got stuck on slide 6, so we're going to look at that as a class. Now, if I'm looking at this slide, all right, the goal is to get my answer to go through all those blue y-intercepts while also going through this open black dot right here. So let's just go from bottom to top. Now, you need to pay attention to what your axes are going up by, because sometimes the dash marks are not always going up by 1, so be careful about that. So this first one, this one right here, what's my y-intercept? Where's it at? It's at 1, because the dash marks are going up by 2s on the y-axis. So my a value here is equal to 1. Now, the next thing you need to ask yourself is, what do I need to multiply to get from 1 to a y value of 8? Because our x values are going up in steps of 1. So we can just figure out how we multiply from 1 to 8 to get our b value. So what do we get? H. So that means b is equal to 8. So this first one is going to be y equals 1 times 8 raised to the x power. All right. That's your first one. The next one, so right here. What's the y-intercept there? Or what y value is that y-intercept at? Look at yours, guys. It might be hurting on mine, but you got the same thing. It's at 6. So that means my a value for this one is 6. Now, how do I get from 6 to 8? So guys, when in doubt, divide the higher x value, y value, by the lower x value, y value in your calculator. So do 8 divided by 6, see what you get. So then it's going to give you a decimal. So then I want you to hit the math key, which is right below that green alpha key, and then hit enter twice. It'll convert that decimal to a fraction. What'd you get? 4/3? So our b value here is 4/3. So that means this is y equals 6 times 4/3 raised to the x power. Our last one is right here. All right. What's the x value right there? Or the y value, sorry. That's 16. So your a for this one is equal to 16. All right. Now, how do I get from 8 to 16? Or actually from 16 to 8, I should say. 16 to 8. How do I get from it? You multiply by 1/2. Because technically, you divide by 2 to get from 16 to 8. But that's the same thing as multiplying by 1/2. You want to know what number you're multiplying to get from x value of 0 to x value of 1. All right. So if you do that, you would get y is equal to 16 times 1/2 all raised to the x power. And if we check ourselves, it works for all of them. All right, so that's how you go from graph to function. You get the y-intercept first. Then you figure out how you get from an x value of 0 to an x value of 1, which you have to multiply to it. All right, that's how you get your b value. Does that make sense? All right, so we're going to put that away for right now. That was just kind of to get your juices thinking, or the mind juices flowing for how to do exponential functions. So now I want you to take out that journal entry that the new journal entry that you guys grabbed today. So the one that says exponential growth and decay on it. So heads off desk, my dears. So it's that brand new journal entry that I had you guys grab. So we're basically going to reiterate what we talked about a little bit with our delta map, but this is kind of like the official notes for it. So basic exponential growth and decay. All right. First off, you do have an I can statement for this, so just write this at the top of it if you have room. So 2.2a I can statement is I can write an exponential function given a graph dash ordered pairs dash table or a description of percent growth dash decay. So basically, it's exactly what we've been doing pretty much this whole class period. All right, we're just having official notes on it now. So specifically with growth and decay, all right, this here is the formula for exponential growth. And you see it a little bit different than how I showed it to you. So I showed it to you as y equals a times 1 plus r raised to t value. This is the exact same thing, just different letters. All right. So exponential growth, this capital A is your new value. Your P stands for your principal, which is just a fancy name for initial value. Your R is your rate. Again, that's typically given as a percent in the word problem. And then your T is units of time. So any unit of time, years, months, minutes, whatever. Now, on the other side of things is exponential decay, which again, it's the same formula. The only difference is it has a minus instead of plus, and all the variables mean the exact same thing. Now, when you graph an exponential growth or decay, you could have two different outcomes. So one of those graphs up there is an exponential growth. One of them is an exponential decay. Which one do you think is which? So first off, which graph do you think represents growth? The left or the right one? So let's do this. Hold up one finger for left, two for right. 1, 2, 3, go. All right, it's actually the left. Because when you hear growth, what do you think when you hear the term growth? So when you hear the word growth, besides growing, what do you think? What word do you think of? What's a synonym for growth? Not necessarily the sum.
Ascend.
Oh, ascend. Ascend, increase, appreciate, however you want to put it. So that means it's getting bigger as you're going up. It's going up. So it's a little misleading on this graph, but this is 0, 0 right here, and then the line is going up. So this is actually representing a growth. which means the other graph represents decay. Because when you think decay, you think descending, decreasing, depreciating, however you want to put it. It means it starts high, but it gets low pretty quick. All right, so this is a decay. So knowing the difference is fairly important. Growth means you're growing or increasing. Decay means you're declining or decreasing. All right. Now, let's put that into practice for a couple of examples. So look at this first example here. So it should say, start with Mr. Foster. It should be the first problem in the top left corner on the inside. So, Mr. Foster is starting a new job. His salary for the first year is $30,000. He will receive a 5% raise each year after that. Write a formula to define Mr. Foster's salary for the nth year. So, let's pick out some important information here. Someone raise their hand and tell me one piece of important information that we need. Corey. First year is $30,000. Good. What's another piece of information that we need? Jasmine. 5% raise each year. All right. So, based off of what is said in the problem, do you think this is going to be a growth or decay problem? Growth. How do you know? Right. It says raise, which means growing. When in doubt, there's usually always one word in the word problem that basically either means growth or decay, whether it's increasing or decreasing. So since we have raise, that means we're doing a growth, which means we're using the formula A equals P times 1 plus R to the T power. Now, let's pick out all my variables. So, P is your principal or initial value. What's my initial value here? $30,000 is what I started with. What about R? And I want this as a decimal. 0.05. So your R is technically the 5%, but if you do 5 divided by 100, that gives you 0.05. Now, what did they say to represent T or time? Each year after, or the nth year. So that means instead of T, we're going to put N. All right. And then A, that's our new value, which they told us to use S, so we're going to put S for A. So now we're going to take all of these numbers and variables and plug them into their respective spots in the formula. So this would be S is equal to 30,000 times 1 plus 0.05 raised to the n power. Now I'm not done because I want this simplified to the fullest. So what's the only thing I need to do to make sure it's fully simplified? Do I have an operation I can do somewhere in there? Landon. Right. Go ahead and just add the 1 and the 0.05. So this would actually be S is equal to 30,000 times 1.05 all raised to the n power. So that's the equation I get. Now, since we got the function, we can then answer the next question, which is how much will Mr. Foster make after 7 years? So that's 7 years. Is that going to be plugged in from my S or plugged in from my N? N. Why? It represents time. So this 7 is going to be N equals 7. So we're going to plug in 7 for N in our original formula. All right. So this would be S is equal to 30,000 times 1.05 all raised to the 7th power. And then just like we did earlier, you're just going to take all of this, put it in your calculator. And let's say if you're dealing with money, just always round to the nearest cent. So 2 decimal places. So take a minute, put that in your calculator, and see what you get. And round to 2 decimal places or the nearest cent. So put that exactly in your calculator as you see it and tell me what you get. Gavin. 42,213 point what? 0.101 or 10? 01. Dollars. Don't forget to put your units. So that's how much money he will make after 7 years. Lord, Mr. Foster needs to find a new job. That's how much I make now. And that's saying something. I'm a teacher. Any questions on that one? All right, let's try another one. So, Janet purchases a new car for $25,000. The moment she drove the car off the lot, it began depreciating 15% per year. Write a formula to define the value of Janet's car V after N years. So first off, someone raise your hand, tell me an important piece of information that we need. It's doing what? It's decaying. How do you know? Right, depreciating 15% per year. So because it says depreciating, that means decay. What's another piece of information I need? Corey. Right. New car for $25,000. So you guys are juniors, so some of you have probably bought a car before. As some of you may know, as soon as you drive a car off a car lot, it starts losing value. So for example, if I bought a car today and I tried to sell it tomorrow, I would get paid back less money than what I paid for it. All right. That's just the way it works. So since it's a decay problem, that means we're using the formula A equals P times 1 minus R raised to the T power. So let's just go through our variables and define them. So A, what will be replacing A in this case? V. So the value of our car, or V. So right here. What's going to replace P? 25,000. That's what I started with. What's going to replace R? 0. Oops. 0. Stop. 0.15. My computer doesn't like me right now, guys. Because remember, we take that 15%, divide it by 100 to get our R value. And then finally, what am I replacing the T with? N. Because it says after N years. So I'm just going to take all those values and plug it into my formula. So I get V is equal to 25,000 times 1 minus 0.15, all raised to the N power. And again, I'm just going to go ahead and simplify what's in the parentheses. So you can put that in your calculator, but if you do that, you should get V equals 25,000 times 0.85, all raised to the N power. So if you haven't noticed, typically a growth is going to have a B value greater than 1. A decay is going to have a B value less than 1. All right. So the next part asks us how much is Janet's car worth after 4 years. So again, 4 is your N value, so N equals 4. And we're just going to plug that 4 in for n in our formula. So I would have V equals 25,000 times 0.85 all raised to the 4th power. And then just put this in your calculator and tell me what you get. Mm-hmm. So it's 13,000 what? Point 17. Yeah. Mm-hmm. Yeah. 17 or 16? 16. So my value of the car after 4 years would be $13,050.16. So any questions on those two? All right. Try that last problem on your own. So take a minute, try that last problem on your own. Or, well, no, there's 2 other problems, but do the very last problem, like right next to the problem we just did. Do that on your own. So the one talking about the ibuprofen, that's the one I want you guys to do. All right, I'll give you guys another minute. Mm-hmm. Mm-hmm. All right. Check your answer. And if you round it a little differently than me on that last part, it's okay. As long as you're kind of within range. Because it didn't specify, so. All right. Any questions on exponential growth and decay? All right. The very last thing that I want to do, look at page 1 of your new packet, and I just want to go over one problem in particular. Look at number 2 of page 1 of your brand new packet that you should have grabbed from the front. Just want to look at problem number 2. So, problem number 2 states, population of 50 fruit flies is increasing at a rate of 6% per day. Which of the following is closest to the number of days it would take for a fruit fly population to double? All right. So instead of finding the x value, we're finding the y. Now, later on in this unit, we're going to learn how to do that algebraically. But for right now, you're going to want to use your calculator and a graph. All right. So there's 2 ways you can do this. You can either A, make a table of values in your calculator, or B, graph in Desmos. All right. And find intersection. So before we can do either of those options, we got to write an equation that represents the scenario. So population of 50 fruit flies at a rate of 6% a day, and it's increasing. So is this an exponential growth or decay? It's growth. So this is my P value. This is my R value. And since it's increasing, that means I'm going to have a plus between that 1 and R. So this would be y equals 50 times 1 plus 0.06 all raised to the t. Or you could rewrite it as y equals 50 times 1.06 all raised to the t. But I'm going to use x in this case. Now, if we're hoping for the fruit fly population to double, that means I'm looking for a y value is equal to what? We want the population to double. What does double mean? Times 2. What did I originally start with times 2? What's that equal to? 100. So I'm looking for when y is equal to 100. Now, the first way you can do this is in your TI, you can make a table and look at that table. So in your TI 84, you would hit y equals at the very top left corner and type in the equation that we just came up with. So 50 times 1.06 all raised to, and then your variable key x is right to the left. It's to the right of the green alpha key, to the x power. Then to make the table, you would hit the blue second key and then the graph key, which is the top rightmost key. And it'll create a table like this. Now, you can use your up and down arrow keys to scroll down the table until you see a y value that is above 100 or close to 100. So when do I have a y value that's really when do I have an x value where the y value is 100 or close to it? Landon, at 12. So that means that when y is equal to 100, x has to be equal to 12. So 12 years. So this one. Now, the other way you could have done it is in Desmos. So the way you would do this in Desmos is you would make a graph of this, make a graph of this, and find the point of intersection. All right. So in Desmos, I would type in my function that I came up with originally. So y equals 50 times 1.06, all raised to the x power. And then y equals 100 in a separate box. And you may have to zoom out a bit. But I'm just going to keep zooming out until I see both graphs. Now, I'm looking for the point that the two graphs cross each other, which is right here. And I'm looking specifically at the x value of that point because, again, we're solving for x, so we want to look at the x value. If I rounded that value, what would I get? 12. So the exact same answer that we got. So that's two different ways that you could do the same problem. All right. So either way you do it, you would still get an answer of 12. So for right now, if I asked you to do that, you would just use your calculator for right now. We'll learn how to solve algebraically later. But for right now, that's just using your calculator. Any questions on that one? All right. So you guys got a solid 20 minutes until class ends. So you can either work on your intro Delta Math, finish working on that, or you can work on pages 1 and 2 of your packet. Actually, no, I lied. It's pages 1, 2, 3, and 4 of your packet. So pages 2 through 4 of your packet is the assignment for this lesson. But the Delta Math's a priority, so I would work on finishing up that Delta Math. And then here's the exit ticket for today. Well, and if you can't see it, it's also cross-posted in Canvas under the exit ticket page.